Hello everyone, my name is Syed Ali Abid Rizvi and I'm presenting ENGG851 assessment 3, and my research topic is a scheduling algorithm for Enterprise IEEE 802.11 AC WLAN. First of all, what is WLAN? It's the main component of, if we talk about 802.11 AC standard, uh, it's enforced on WLAN networks. What is WLAN? WLAN is a local area network. It could be of home, an office, or a shopping mall. And all the devices in it are connected to each other wirelessly. And the devices could be your laptop, your PDAs, your mobile phones, your any tablet, anything like that. IEEE 802.11 AC. IEEE 802.11 is it's just a family of standards that are enforced in order to run it a wireless local area network. IEEE and 802.11 AC is just a part of 802.11 standard, and it was approved in 2014. What does it do? What is it used for? It's used for providing 1 gigabytes of data speed, and it's only possible when there are multiple antennas and different features are being used all together. So, what are IEEE 802.11 AC standard? Features. The channel bandwidth, if you see, it's backward compatible. And what channel bandwidth does it you can have in it is 20, 40, 80 megahertz per second. Oh, sorry, megahertz. And it also provides a optional feature of 160 megahertz megahertz second, the channel bandwidth. The channel coding schemes that are used in it are binary convolution coding. It's the main feature, main coding scheme that is used in 802.11 AC. What are the other things that are important in this feature? Low density parity check, the space-time block coding, the modulation schemes that are really important are 256 QM, quadrature amplitude modulation. It supports up to 128 spatial streams. It also has a beam forming function, and then it has a guard band of 800 nanoseconds and another guard band of 400 nanoseconds. So now about the features that 802.11 AC uses. Low density parity check. It's just an error correction method that is used in order to transmit the signal when there is over and noisy. When there is interference in the signal, we use low density parity check in order to transmit our signal. Then what is space-time block coding? It's just like transferring different streams of data at a time from multiple antennas. What does it do? There are different antennas, and all of the antennas are used, and they transmit same data from different antennas. And what about guard band of 800 nanoseconds? 800 nanoseconds is a regular guard band, and 400 nanoseconds is used as a guard band, and it's just a short guard band, and it's just like if you use a shorter guard band, the amount of data that is going to be transferred is going to be high, because a lot of time is being saved by having a shorter guard band. And one of its other features is 256 quadrature amplitude QM modulation technique. What does it do? It's just a 256 signals combination. You can transfer 256 different type of signals in one in a go. And each symbol has 8 megabits, so you can 8 bits, so you can have transmission rate 8 times more than like you can have 25 to 256 different type of signals in a time, and the data rate would be higher than the signal rate. And beamforming and spatial stream. Beamforming is a technique of uh, transferring a signal in a direction, and spatial means same time different types of spatial. If there is a multiple antenna and the signals are transferred to different directionally towards the systems. And what the main two techniques that make that are used by IEEE 802.11 AC in order to transfer the data at a speed of very high throughput of 1 Gbps is channel bonding and multiple input, multiple output technique. First of all, what is channel bonding? Channel bonding supports it supports a bandwidth of 20, 40, 80 and 160 megahertz. What does it do? Channel bonding means it's just like two different channels can be used to transfer your signal. Like the combination, in order to make a combination of 80 megahertz bandwidth and a 160 megahertz bandwidth. So a small band of 20 and a small band of 20 and a higher band of a small band of 40 and a higher band of 80 can be used in order to get a higher bandwidth. And the other thing that is most important is 80 megahertz, and 80 megahertz of two bandwidths are used in order to get 160 megahertz of data. This is really important in order to get 1 Gbps data rate. And both the signals would be adjacent to each other and they wouldn't be overlapping each other. The other most important technique is multi-user, multiple input, multiple output. What does the name say? Multiple input means there are multiple inputs, multiple output means there are multiple outputs, and multi-user means multiple users can use that system. So as the name says, uses it uses multiple antennas. There are multiple antennas, then transmit, receive data streams simultaneously. So what does it do? There are multiple antennas, they transmit the same signal to the device multiply, and they can receive the same data stream from multiple sources, from multiple destination towards them. And what is used in, how does the mechanism work? So there is channel state information, CSI, and whenever they are transmitting, they ask the other system for RTS and CTS. RTS mean request to send, and CTS mean clear to send. So this is the way they don't overlap each other, and there is no interference with the different outputs or the transmission or the receiver. User transfer beamforming. So beamforming is just like, as I told you in the beginning, beamforming is a way of targeting a user, like directionally directing your beamform towards a signal. Conclusion. So IEEE 802 is flexible, as you all know, and it's provide connectivity, and it's backward compatible. So it's really like easy to enforce on the wireless networks. And IEEE provides a throughput of 1 Gbps. So using the channel bonding and multiple user, multiple input, multiple output technique, you can enforce 1 Gbps signal, 1 Gbps throughput of very high throughput of 1 Gbps. That was my presentation. Thank you for the